Well, good afternoon, everyone. Good morning for some of you. My name is Brian Moore, and I'm the SVP of Sales and Marketing here at Conducive Technologies. And with me on the line is also a guy who's been here at the company for just a couple of years. He is our SVP of Technology Strategy, Gary Kwan. We affectionately refer to him as GQ. So GQ, if you're on the line, why don't you join in, tell the folks hi.
Well, glad to be here, Brian. And although Brian has his title SVP Marketing, don't let him fool you. He's very technical minded. I'm just here to help him out.
Well, and sometimes end up needing a lot of help, GQ. So appreciate you being on the line. I know we have technologists on the line, so they put up with us, sales and marketing guys, but really they want to hear from the technologists. We're here today to talk about our IO reduction software solution, how we guarantee 2x faster SQL performance. And so this is just a very quick product overview of what our software does. Right after the webinar is over, per what you received earlier, you will be receiving a download link to an NFR, a free NFR, a not-for-resale version of our software, a $3.99 value, that you can take that software. It's a perpetual license that you own in perpetuity, and you can download it. You can install it straight into one of your hardest hitting SQL server, and the proof is in the pudding. So we can talk about features in theory, but the proof is in the pudding, and we're going to give you access to the software. This is not just a product overview, but really this is a deep dive into what are the inherent I/O inefficiencies that are occurring under the hood, in your hardware stack. What is the software problem that's causing your hardware to process workloads at least 50% slower than they really should? So just to set the table here, just to give you kind of the nosebleed high level of what our software is. It's just, as I mentioned, it's I/O reduction software. It's a 100% software approach to boosting SQL performance. There's inherent inefficiencies that cause SQL to run much slower than it should. I will explain that in a minute. But the software itself, it's something that you just install straight into the Windows operating system on a virtual server. It can be also installed on a physical server. And you just install the software, reboot, and the software then is active and running quietly, transparently in the background at near zero overhead. You won't even be able to see the CPU footprint, just a very thin filter driver. And what it's doing is it's offloading I/O from your underlying hybrid or flash storage, and it's streamlining whatever I/O traffic remains so it can be processed much quicker by your underlying storage device. And this is how our customers, now we now have over 2,500 customers have the software deployed, both mid-market, large enterprise customers using the software. And you may wonder, who is Conducive Technologies? Not going to spend a lot of time on this slide. I don't like getting into presentations when they do. But if you haven't heard of us, you may want to know, well, what kind of street cred do we have to even be speaking about the topic that we're talking about today? And we're a 35-year-old software company, 12th oldest software company in the world. We're formerly known as Diskkeeper, known for years and years as the #1 defrag utility for Windows systems. But what we're doing now has absolutely nothing to do with defrag. Almost 5 years ago, we pivoted with our IP and introduced some really revolutionary technology to really help virtualize organizations. You're running I/O-intensive systems that were running in inefficiencies that slow performance. And when we brought this technology to market, Gartner named us Cool Vendor of the Year, Storage Magazine named us Storage Software Product of the Year. As mentioned, we've now ramped up to over 2,500 mid-market large enterprise customers using us on their hardest hitting I/O-intensive systems, 7 out of 10 of them being SQL Server systems. And if you haven't heard of us, you've certainly heard of all of our OEM partners: Samsung, HP, Dell, Lenovo, SanDisk, Western Digital, just to name a few, and very close relationships with Microsoft and VMware. In fact, GQ, last month, I know you were steering this, we were named by Microsoft the first ever software vendor certified for their SQL I/O reliability program.
And you're right, Brian. I'm kind of proud of this because Microsoft has these certain certifications for their products to make sure that third-party products like ours are completely compatible and reliable on their platforms. And This one here with Microsoft SQL Server, I kind of consider elite. There's no other software and not very many hardware. The only other hardware vendors were elite companies with EMC, Dell, and HP.
Yep.
So this is great, Brian.
Yep. So now Charles already has a question, and glad to see that Charles found the Q&A box. I should mention to everyone that is online right now, if you don't have the Q&A box open on the bottom right-hand side, you'll see the icon in your panel on the upper right. Just click on Q&A and write in your question or comment. Just address it to all panelists so that both GQ and I can see it. And we'll answer some of these questions as we go along, and we will do a full Q&A when we reach the bottom of this. Shouldn't take more than a 20-minute run through to give you the overview, and then we'll stay on for as much Q&A as you have. And Charles asked, hey, is this software, is it only for VM? Can it be used in an AWS or Azure or physical hardware? And Charles' answer to that is yes. Most of our customers are running it on their virtualized servers, but we do have many customers that are running it on their SQL instances that are in the cloud, or on their physical servers. In fact, GQ, you recently published a paper that was part of that SQL reliability program with Microsoft, and it was all about showing how we improve transactions per minute on a SQL instance in Azure. Isn't that right?
That's correct, and we showed about a 40% gain in that one test there, and that's on kind of the low side there, Brian.
Yeah. Well, and that's because in that particular test did not follow what our best practice is that we'll share just a little bit that helps customers get into that 2x gain. Now, just to give you one quick bit of marketing data, we conducted what we believe was the largest independent study done on I/O performance earlier in the year. We polled hundreds of IT professionals, and one of the questions we asked is, regarding your applications that are running on top of SQL, how many of you have performance problems so severe that you're actually getting complaints right now from customers or staff about sluggish performance? And when we asked that question, there was 27% of organizations who raised their hand and said that was them. So likely the reason that you're here on the webinar is because you are having queries or reports or batch jobs that are taking just too long, or maybe even getting those complaints. And we're just letting you know that you're in good company. There's a lot of other organizations experiencing the same thing, and it's exactly why our solution has ramped up the way that it has so quickly. In fact, any time that we get a new customer who comes with our software is agnostic to the application. If it's an I/O intensive application, that's what people deploy us for. But for that reason, what we've discovered is that 7 out of 10 new customers, they're deploying us to boost SQL performance. And it's not just because it's the most I/O intensive system out there for most organizations. It's also because SQL is inherently inefficient in how it processes its I/O. And that's why, really, for us, it's become the killer app of why customers use our software in the first place. So the screen in front of you, just to kind of get under the hood and tell you what's going on, what is the problem, and what are we doing to solve it. So if we were to take an abstraction of your hardware stack and look at your I/O profile, the I/O stream, and this right here in front of you is really an abstraction of what a healthy I/O stream would look like or should look like if your systems are achieving optimal performance. You can take a look at the screen in front of you. You see the emphasis is on the I/O and the relative density to that I/O. As you can see, you're getting nice, large, clean, contiguous writes and reads. You're getting nice sequential traffic. But as much as that's ideal to get optimal performance, if you take a look at this very next slide, well, this is what you get if you are running a Windows server in a virtualized environment. This is the type of I/O stream that you're getting if our software is not installed. There's actually 2 different I/O penalties that are causing your systems to process workloads much slower than they should. The first penalty actually has to do with virtualization itself. That's called the I/O blender effect. It's actually a term that we helped Gartner coin when virtualization just came on the landscape. And when you're in a physical environment, you get, there's a one-to-one relationship between server and storage. You get sequential traffic. But the moment that you virtualize, all those disparate VMs sitting on the same host hypervisor, those I/O streams are now mixed and randomized, delivering a very randomized pattern to storage. And the more guest machines you add, well, then the more random that profile becomes, because you're now mixing and randomizing more I/O, creating this chaos or this I/O blender effect of randomized I/O, which really dampens performance, whether or not you are running hybrid storage or flash storage. Particularly chokes write performance in a tough way. But as great as virtualization is for efficiency, the one downside is how it adds complexity to the data path and causes applications to slow. Now, GQ, most organizations, when they virtualize slowly, one system at a time. They don't necessarily see that performance impact going from physical to virtual because they virtualize over time. But some of our customers are those customers who actually went from 100% physical to 100% virtual overnight and saw massive performance problems, and that's why they came to us. In fact, one of those that you worked with was one of the largest healthcare systems in the nation with Chris's Health.
You're right, Brian. And what they did is they actually virtualized 2,500 other systems all at once. And like many companies, they were thinking, they did test it out, but they didn't do all the performance testing. But when they went from physical to virtual, they thought, I'm going to keep the same performance. Well, they didn't. They saw major performance degradation. And after analysis, we found out it was an I/O bottleneck issue. And at first they were trying to find a quick solution for it, and they were looking at a $2 million overhaul of their storage to go to all flash array. But what they did is they came to us and they put us on there, and we solved their I/O bottleneck issue and prevented them to have to spend that $2 million right there. So it was a nice success story right there, Brian.
Yeah. Now, this issue of the I/O blender effect and and the associated performance penalty from that, there's actually, as tough as that one is, there's actually a worse I/O tax or worse I/O penalty happening further up the stack, and that actually has to do with the Windows operating system itself. We call it the Windows I/O tax. Windows just does not play well in a virtual environment. It doesn't play well in any environment where it's abstracted from the physical layer. It doesn't own the physical layer where the data physically lives, so that's the responsibility of your controllers on whatever storage device that you're running. And as a result, there's this inefficiency in the handoff of data between Windows and the underlying storage. And what happens is that Windows, because it's never looking for the best available allocation within the logical disk layer outside your underlying storage, but within the file system itself, Windows ends up taking any given file and breaks it down to be much smaller than it needs to be. And as a result, you get this surplus of excessively small, tiny writes and reads that are then subsequently randomized by the I/O blender effect at the host hypervisor, where you end up getting what we call really the perfect trifecta for bad storage performance. That's small, fractured, random I/O characteristics. And it's essentially, it's a death by thousand cut scenario. A good example of this, we recently published a case study with the University of Illinois. They were running all flash arrays to support their hardest hitting both SQL and Oracle applications. After about a year, their database performance began to slow. They were looking at purchasing more expensive, all-flash arrays to make up for the difference. But before they did that, we thought, you know what? We might as well give these Conducive guys a try. We've heard about what we've done for other customers. They installed our software, and we more than doubled their performance. In some cases, we quadrupled their application performance on some of those databases. And it was a good example where they just couldn't believe that it were these I/O degradation issues that were causing their systems to be as inefficient as they were. So GQ, I'm going to tee you up here just a minute for our audience because we're just going to describe very quickly what our software is doing to solve these inefficiencies and drive the performance gains, and then we'll move to Q&A and make sure everyone gets a download link. But our software actually does two things to solve these problems. We have a patented write optimization engine, and we have a patented read optimization engine. And GQ, let's go ahead and talk about that patented write optimization engine first. We mentioned Windows doesn't play well in a virtual environment. It breaks, writes down to be excessively smaller than they really need to be. Maybe you can explain just a little bit what's really going on here, and what is our software doing to solve that problem?
Be glad to, Brian. The Windows file system takes a one-size-fits-all approach. And the reason for it is that, when a file gets created or extended, the file system doesn't know how big that file is going to be when it gets created or extended. So what it does is it sees a file creation. It goes looks for a allocation, where to put this data at. And that allocation is just the next and basically a fixed size. Well, if it's bigger than that, it has to go find another allocation. Well, that other allocation is another I/O, and so forth and so forth. So rather than writing a large file out in one contiguous I/O, it actually writes it out in a whole bunch of small random I/O. And be analogous to this, it's kind of like, you want to carry a gallon of water from one place to another. Would you rather carry it in a big gallon bucket rather than a whole bunch of Dixie cups? And that's what we're doing here. We're allowing the file system, by just giving it data, because what we're doing here is we're monitoring the system in the background. And we know when a file type or application, when it creates or extends a file, it's got to be that big. And we just feed that intelligence back to the file system and let the file system do a better job of writing that data out in a nice, large, contiguous I/O. And if you ever look at benchmarks on storage, they give you two benchmarks, one for random I/O and one for sequential I/O. And you'll always see that the sequential I/O outperformed the random I/O. So that's what we're giving back. We're allowing it to get nice sequential I/O and get the best performance from your storage, Brian.
Now, GQ, I have a couple questions here, but I thought, why don't we go ahead and just explain, we just explained our write optimization engine. Why don't we then explain our read optimization engine, and then we can field a couple of these questions, because as much as GQ kind of outlined what we're doing to eliminate that issue of excessively small, tiny writes and reads and displacing them with large, clean, contiguous writes, that really boosts performance. That has a big impact for customers all by itself. But GQ, that's not the only thing that we're doing. We're actually also doing a read optimization engine that's very, very different from the write optimization engine. And our read optimization engine is a DRAM read caching engine that just dynamically monitors the system to discover how much memory is idle and available, otherwise unused and just going to waste on that system. And we're using that portion of memory to serve hot reads. And GQ, this engine, this has a huge impact in performance, and really the beauty is you don't have to allocate or carve out anything for cache. It's just going to dynamically use what's idle and available. In GQ, we talked about some of our OEM partners. We've sold millions and millions of this DRAM, of licenses of this DRAM caching technology to our OEM partners, some of them the largest organizations in the world.
You're right, Brian. I'm kind of proud of this because 9 out of the top 10 OEM PC manufacturers actually license our caching technology. Now, you haven't heard of us because they license under their name. Same thing with SanDisk and Western Digital. They also license our caching technology. Now, there's a couple of things you mentioned here, Brian. I just want to reiterate the importance of it. And one is how we dynamically use only available or unused memory that's on the system. And if any user or system process comes in and wants to and needs memory, we automatically give it up. So there's never a memory contention issue. They always have first priorities. But what's not being used, we're using it for caching. And caching is the whole concept of, hey, reading data, let me satisfy it right here on the operating system from your DRAM, preventing it having to go all the way down to the network storage. So that's one of the fastest way to get your IOs completed here. Now, caching is not new, but what's different about us is our technology on what to put in cache and keep in cache for the utmost optimal performance. Because we're not only looking at, oh, let me get the best cache hit rate, but we're also looking at what data to keep in there to give you the best performance. It's not the large contiguous reads that hurt performance. It's those small random reads. So we give those priority to put in there because we know that is degrading your performance. And if we can get rid of those, we're giving you performance back. So Brian,
yeah,
we got the reads and the writes here to get the performance back.
And one of the first questions that we do get asked is, sometimes someone thinks that they have to be really capacity intensive in order for them to get a boost. They think they have to have a lot of DRAM, available DRAM sitting there to get this boost. And GQ, simply because DRAM is 15 times faster than SSD sitting below it, they only need a sliver of capacity for this to deliver big gains, don't they? In fact, we commonly see customers that even if they have just 2 gig of idle unused memory sitting there, if we're able to put that to good use, we can oftentimes serve up to 50% of the read traffic in GQ. If there's even 4 gig, we're going to commonly almost always see 50% or more of their read traffic offloaded from storage.
Exactly, Brian. And SQL is not very, SQL has caching, but it's not very smart on what it does. All it does is say, hey, let me take all my memory, let me load all my databases in there, and hope that some of these will get read, because a lot of database getting put in there aren't even accessed. And we had a third-party lab do some testing where they limited what SQL did, gave us some memory, and we improved the transaction rates by 60% in that one case, Brian.
Yeah, well, and that's also a case in point of across all of our 20-plus case studies, all of them cite a minimum of doubling in performance. It is for that reason. Now, GQ, Todd has a good question here, and it's an overhead-related issue. Understands we're driving a benefit, but he's wondering, how many CPU or RAM resources are we actually taking that could impact other applications? So essentially, are we robbing Peter to pay Paul when it comes to doing these optimizations? What does our overhead look like?
And you know what? And I know as Todd was looking at the consolidation process, or how we make sure the writes are nice contiguous. Actually, Todd, almost zero overhead, because what we're doing here, first of all, we're doing in the background the monitoring of trying to see when a file gets created, it's got to be this big, or get extended this big by file types or application. Now, when a file gets created or extended and comes through the file system, we just add data or give intelligence back to the file system saying, hey, this file getting created, it's going to be actually this big. And the file system just takes that intelligence itself and finds the best allocation, so it's a nice contiguous I/O. So we don't have any overhead, or I don't want to say any, but very minimal, insignificant there. I hope that answers your question.
We challenge our customers to even see the CPU footprint of what we're doing, and it does, Todd, run at low priority. So if for any reason, you'd mentioned, hey, what if a host ends up being 80, 90% or more utilized, even the optimizations that we do, they're running at lowest priority. So if resources are taken, well then our optimizations are going to back off completely. And as GQ mentioned, this is not a consolidation. We're not doing buffering. We're not doing coalescing. All of those are high overhead, CPU intensive types approaches. What we're doing is, as a very thin filter drivers, we're just feeding in intelligence to the Windows operating system, help do a better job of choosing the best allocation instead of the next available, which is very rarely ever the right size. Now, GQ, let's go ahead and field. I know we will go to a full Q&A, but Senthil asked this question. He goes, how is the software different from, let's say, like a Fusion I/O card? You know, if someone's looking to boost performance, they might do something like a Fusion IO card that would, you know, cache, you know, at the host level. But what we're doing is we're actually offloading IO even above that. In fact, you know, a number of our customers, they do run a Fusion IO card server side. What we're doing is we're offloading, you know, inefficient IO from actually hitting that Fusion IO card in the first place, one with our Tier 0 cache strategy using DRAM, but then also just making sure the IO that does get served is optimal IO. You're getting a nice, clean, contiguous writes and reads instead of that Fusion IO card getting bogged down by a surplus of an excessively small, tiny writes and reads. Anything you need to add to that, GQ?
No, Brian, you hit it on the nail there, and that is, first of all, the DRAM is the fastest response time. If we can satisfy from DRAM, that's the fastest. Although, you know, the SSDs and the Fusion IO cards are fast, DRAMs is faster. And then what you said, we're delivering nice sequential IO down to these SSDs and Fusion IO. And same thing as I said before, if you look at the benchmarks, the sequential write IOs always outperform the random IOs.
Yep. So, GQ, sorry for our audience. We were talking about a read optimization engine. I had us on the wrong slide, so I hope I didn't confuse anybody. Now, just to take a look in front of you, you may wonder, well, how about some real-world, you know, customer examples? I'm not going to give you all of these. This is just for you to view on screen. I'll just call out a couple here. You know, ASL Marketing, they had a SQL import batch job. It was taking them 27 hours, absolutely killing them. They were considering doing a forklift upgrade to their back-end storage. But before they did, you know, they installed our software, and they just couldn't believe what our software did. We dropped it from 27 hours to 12 hours. It was a 15-hour reduction. They just had no idea, you know, this I/O degradation under the hood, you know, that was stealing their performance. This is just another example here. Stockport College, you know, they actually crashed on enrollment day from I/O demand. It was taking 15 minutes on average to process one student record. They installed our software. They didn't have it in budget to do a rip and replace of their back-end storage, so they just were crossing their fingers and hoping we could help. And we dropped that 15-minute average down to 5 minutes, and they couldn't believe it. In fact, so much success there, they put us on their payroll batch jobs that were reports that were taking an hour and a half, and even this is one I couldn't believe. We cut that hour and a half to 10 minutes. So that just gives you just a little bit of an idea of, you know, what is happening under the hood, you know, that steals performance. And this next slide is just more customer examples. These are more recent sales that we've had, just examples of problems that customers faced and when they came to us, what we did to solve. You can read them there. I'll just mention one. Alberta University, they had an LMS app that was running on their SQL. Students were timing out during tests due to I/O demand that was causing the timeouts. They didn't have it in budget for all flash off their hybrid system, so they turned our software. We doubled performance, and we stopped all of their timeouts. So that's just to kind of give you a quick example. Now, once you do receive the software and install the software, you know, clearly there are those prospective customers that do their own third-party, you know, independent validation. You have the before and after performance gains. We see some customers simply just look at their storage UI and watch how their daily average IOPS drops, you know, after the software is installed. We see customers who do something as rudimentary as a stopwatch test, where they time SQLs or queries or batch jobs without our software, install our software, and then, you know, retime those same queries or reports. But the GQ, the product itself actually comes with its own dashboard, and a lot of people just rely on the in-product dashboard because the dashboard is fully transparent to the types of performance gains that you're getting on a particular system. It shows you the total IOs that we're eliminating from storage, shows you the percentage of your read and write traffic that we're offloading from storage. But more importantly, since we're sitting there at that application layer, you know, we know exactly what the latency would have been if your underlying storage had to serve those IOs, and we're put together an aggregator or a counter of the amount of time we're actually saving any given system. So puts to you in the terms of the benefit that you need to socialize internally with management, and that's, you know, how much actual time are you saving from using the software.
Exactly.
So this next, I'm sorry, GQ, please jump in.
I just wanted to mention, because Justin asked, this is perfect for what he asked. He said, he worked with our support folks over a year ago with the IO analysis tool, and it showed that our product would get great improvement, but he couldn't get the executives to buy in on it. With this dashboard, it gives him the data to present to them to show the benefits of the product. Just install it on the system, let it run for, I like to say 5 days to 2 weeks, and then bring it up. And you can show what gains the product's giving back to you. So this is great for the question Justin had.
Yep. Now we're just about to move to Q&A, but now that you're just about to receive the software, we just want to give you these 3 steps. How can we guarantee a 2x faster SQL experience? Well, step 1, if you can, it's always a good idea to beef up memory server side, especially if you feel that you may be memory constrained. The most cost-effective way for you to drive more performance is with this tier 0 DRAM cache strategy. The more memory that you give and you can commit, the more you're going to get back. And step 2 is very, very important, GQ. We know that most administrators, they'll cap their SQL memory usage, leaving 4 gig for the OS, following Microsoft's best practice. But in our case, maybe you can explain just a little bit. In our case, you want to cap SQL a little bit more aggressively. As a minimum, you want to leave at least 8 gig for the operating system, because our software will then pick up whatever is left idle and available. We have found in our experience with customers that having about 4 gig that we can work with is usually really the sweet spot. And GQ, the reason it's important is just because unless SQL is capped, SQL is just going to take all the memory and nothing will be sitting there as idle and available for us to pick up.
You're right, Brian. As I indicated before, SQL is not very smart on how it uses the memory. It just says, let me take all the memory, let me just load as many databases as I can into it, and not concerning how to, what database you're getting hit the most. So that's where we come in. Cap it, give us some of that available memory, and we're going to give you some big gains.
Now, we do have some customers that, they have some really hard-hitting SQL systems, and they're needing the absolute most performance possible. Now, in those cases, our cache can be leveraged. We can leverage up to 128 gig of RAM, and in those cases, those customers that are they're trying to get way more than the 2x gains. They're looking for the as fast as possible gains, the otherworldly gains. And if you're in that camp, the way you do that is, if you want to maximize the amount used for cache, add an additional 128 gig of RAM to that system, cap SQL to what it's currently using, so that extra 128 gig of RAM that you added goes to us that we can use. And that's where you're going to get into the big gains, just because DRAM is so fast. And then step 3, as GQ mentioned, all you have to do is just install the software, reboot the system, and the software's active. Usually takes 24 hours to 48 hours for the algorithms to adjust, but what we suggest is waiting about 5 days, and after about 5 days, pull up our UI. And what you're looking for is that 50% reduction in I/O traffic to storage. When you see that 50% threshold where we're offloading 50% of I/O, that's where you can pretty much bet the badge that you're getting a 2x faster SQL experience or faster, barring any delivery issues over the network to the user. And just finally, last slide here, and then we'll go to Q&A. Your next step options, you will be getting the NFR, free NFR perpetual license. You can take it, you can download it, you can install it on one SQL system. As mentioned, you cap SQL before you do the installation. Or the next step that you could do is, you could really, if you want to, engage us. We could connect you with one of our SCs. If you want to install our centralized console, a centralized management console, and you want to do this test on more than one system, but you want to do it across several systems, then you just want to contact your account manager over email. Let them know you'd like to do a real POC and get the 30-day version across several different that can be pushed out across all the systems you have on the same host hypervisor. And GQ, as much as they could take the software, install the one instance of our software on one SQL server, The only problem is that they won't see the full power of what the software can do because there's still other guest machines sitting next to it that are sending down anywhere from 30 to 40% of just noisy, unnecessary I/O. That's interfering for resources and really creating chatty neighbor issues. And the only way someone can really see the full power of what the software can do is if they actually try it on all the VMs on the same host.
And you're right, Brian, and this answers a question from Mike, because he says, does this need to be installed on all VMs? No, you can just install it on, your hard-hitting VMs, but as Brian indicated, those other VMs are also causing those I/O, that I/O blender effect. So by putting it on all the VMs and optimizing the I/O, you're actually increasing the bandwidth for your other VMs too. So that's why we recommend put it on all your VMs. And Brian, I'll tell you, one of our licensing models is you buy a license for the host, and you can install it on all the VMs on that host. So it's perfect in that case.
Yep. So you will be receiving an email from your account manager that contains the download link, any help or assistance that you feel that you may need. I mean, if you're just downloading the single, a local UI of the software, well then it's going to be pretty easy for you just to install that yourself. But if you do want to do a broader evaluation across multiple servers, it's going to take no more than 20 minutes for our SC just to help you stand up our centralized management console and push it out to as many servers as you would like to see the software run on. So with that said, we'll go ahead and move to our Q&A session. I know, GQ, we got a few questions here that have come in. If you haven't asked your question already, just type it into the Q&A box, address it to all panelists, and we'll hang on here for as long as you have questions. And GQ has moved by, and I hope I didn't just absolutely murder that when I said it. He asked this question. He said, does this still apply when we configure Windows to have a certain block size? Now, we know that if somebody has a block size, anywhere from 4K to 64K, we may not be as beneficial if somebody's doing a 4K, but we rarely see that. If somebody's configuring a larger block size, we're certainly going to deliver gains for them, aren't we?
That's true. And for Mr. Tandell, I took the easy route there, Brian. For Mr. Tandell, answering him back, yes, we'll adjust to the different block sizes. So no problem on that.
All right. Now, Todd has a great comment here. It says, hey, our SAN, it already does the sequential, consolidation, before it writes, so, aren't we really kind of duplicating that process? And Todd, I'm really glad that you asked that, because you're right. Every SAN platform, every SAN controller is doing their own proprietary thing on how it actually physically lays out the data. The problem that your underlying SAN has, though, is it can't tell Windows how to give it the data. So as much as the SAN, let's say the SAN is receiving a 64K, let's say that there's a 64K file. Windows may send that down as, as 8 separate chunks, which means it's going to take 8 separate I/O operations to process. So what will happen is that your SAN will take those 8 separate chunks, and it will do a sequential consolidation before it writes it out. But in order for it to have written it out, it means it's incurred 8 I/O operations to write it out. And then every time it's subsequently read, how many I/O is that going to take? It's going to take 8 I/O to read it. Well, what are we doing? We're ensuring that what gets passed down to the SAN is going to be at the optimal size in the first place. So what it means is we're eliminating the I/O overhead issue. So you'll see that the I/O requirement for any given workload will be dramatically reduced, whereas right now it may be requiring you, a given workload might, let's say you're processing a gig of data, it might be requiring 100,000 I/O to do that. Well, we just might cut that I/O requirement in half. So now you're getting it, writing it, and reading it much quicker.
Couldn't said it better, Brian. Nice job. I see Todd asked, how does it handle DAG clusters, 4x4 nodes? I'll tell you, Todd, I'm not an expert on DAG clusters, but from what I understand, it will create a kind of like a failover cluster. And we work fine on, these like the active passive with the failover clusters, we work fine in those situations.
So Adrian has an interesting question here. He goes, are there any WMI stats I should look at that show that there is a need for your tool? How do I tell which of our systems are I/O constrained? And Adrian, glad you asked that. We do have a free tool, which is really an I/O bottleneck finder. And it's a free tool that prospective customers will often run. It will take a look and do an analysis, or actually it will aggregate data, all your Windows performance data. It will aggregate that data, let's say, over 5 days. And then at the end of that 5 days, it runs and it spits out a report. It does some analysis, and it's looking for it's looking for deviations that are, that deviate too far from the mean. And we look across 13 different metrics, and then we list out all your servers in red, yellow, green, according to whether or not we see them as being I/O constrained. So if you don't already know where your problem child is, well then you just may, when you get that email from your Conducive account manager, you might want to ask them for this I/O bottleneck finder, this monitoring tool that we have, and that might be the first step that you want to take before you actually deploy the software.
And the actual name for it, Adrian, is the I/O assessment tool. So just bring that up, and they'll help get it to you. Let's see here.
Well, we have a well, I like this softball. This question here. Really, after you're running the trial and seeing the performance boost, it goes, his very next question is just going to be, how quickly can I get a quote? What does the software cost? So MSRP on the per system pricing is $399 per server, but we do have host-based pricing available. If you have more than 7 VMs on a single host, you'll definitely want to go the route of the host-based pricing, and that runs around $2,800 per host server. Add 1 year of maintenance support to it, and now maybe you're up in the $3,500 ballpark. But that's if you're only buying one. That's our lowest volume tier, and that pricing is clearly going to scale with volume. So you can ask those questions with your account manager, and they're more than happy to work with whoever your reseller is and get a quote for you to push around internally.
I see Mike asked, do you recommend in excess of 256 gigabyte RAM? Well, Mike, I don't know on your system how much of that RAM is actually getting used. And so, as Brian indicated, 4 gigabytes, which is small compared to that, is our sweet spot. But it all depends upon, your I/O activity. Maybe you're reading a lot of large files, so yes, we could use it. And we can use up to, as Brian indicated earlier, 128 gigabytes of that RAM. And Vincent Till asked, does this software work with SQL clusters? Yes, we do. Work fine with it. And he said we have a 3 instance on a 3-node cluster. We will work fine on that. Let's see here.
P asks, hey, GQ, are we going to be able to show meaningful improvement of a SQL-based, I guess it looks like he has a SQL-based web server. It's a customer-facing website. Yes, Pete, we do have a number of our customers that are running our software to boost the performance of web servers. Again, the proof is in the pudding of what you see once you install the software and try it and experience it. And particularly, web servers have a tendency to be very read intensive. And so in those situations, it makes a lot of sense to try to have as much memory beefed up and SQL capped to make sure we can drive as strong a gains as possible in that situation. So really buy into the tier 0 cache strategy on a web server. Michael says, do you support Oracle as well as SQL Server? I did mention Oracle earlier. We had that case study with the University of Illinois. They installed us on both their SQL Server instances and their Oracle instances. As long as Oracle is running on the Windows OS, then the answer to that is yes. We don't support Linux or other platforms at this time, but only the Windows operating system right now.
Same thing with Charles. Charles says, does this do anything for SSAS besides SQL? And, you know, I should mention here, Brian, you know, we're talking about SQL servers here, but our product works on anything that is very I/O intensive. I know we're just talking about SQL here, but we've got our product installed on file servers, you know, Exchange servers, all these different types of servers where it's I/O intensive, and we're giving the same type of gains back to the users on these other server types, platforms.
Yep. All right, well, GQ, I don't see any other questions at this time that we need to field. If for whatever reason we missed your question, or we have something else, or you have something else you didn't bring up, you can just bring that up with your account manager over email. Ask them. We can have a quick call, facilitate whatever question that you have. If you'd like any hand-holding in the deployment process, we're also happy to do that. We offer full, you know, pre-sales support for whatever your need might be. And if you are wanting to do what we call a real POC of the software, getting it across all the VMs on a single host, or perhaps you have a cluster wanted on all the VMs, you're sitting on that cluster to see what the software can really do. That's where we're going to drive the big gains. We can help you. It's a very quick and painless POC to help you. And we look forward to chatting with you. So GQ, any final remarks on your end?
No, I like being interactive with the users here. And, you know, if we didn't get to your question, please send it in to your respective sales rep, and we will get it answered for you. Thank you very much.
Yep, we'd like to thank everyone for joining today, and we look forward to chatting with you soon and look forward to hearing your results. Thank you.